Okay, 1.4, perimeter and area in the coordinate plane. The coordinate plane is an XY grid, a graph, right? So it's sometimes called an XY plane or an XY grid, but that means we're gonna be looking at these things on graphs. Okay, but before we get there, we got some vocab. A polygon is a closed two-dimensional figure made of line segments. Okay, so the easiest way for me to show you polygons is just to draw some polygons. So a triangle is a polygon, or a parallelogram. That qualifies. All of these kind of shapes are polygons. They don't have to be nice kind of building block polygons. So there's just a random shape I drew, but it's all straight line segments that connect to form that figure. Okay, so some things that are not polygons, a circle is not a polygon. Okay, because it's not made of line segments. If it has any curves at all, it's not going to qualify. If it's not closed, for example, we have a figure like this, it's not closed. The segments don't meet end to end, so not a polygon. Or if they kind of overlap, let's say something like that, that is a disqualification. And it has to be two-dimensional. So if we move into 3 dimensions with a box like that, that is also not a polygon. Okay. There are two major types of polygons, convex and concave. Almost all the polygons we're going to see in the book are convex. Occasionally you might get a concave one. Okay. So an easy way to remember the difference, concave polygons have a cave. So it's kind of like an indentation in those two places, okay? Now that's not a very technical definition, but that's an easy way to remember what is concave. And all the other ones that don't have the caves are convex. So if you look up what a convex polygon is, that means if you draw in any of the diagonals of these figures, that will be inside the figure. So a diagonal just connects two corners, but you don't want to connect two corners that are next to each other. That's not a diagonal, but any other two corners. So those are non-adjacent corners, vertices. So if you attach those, there's a diagonal. I'm not going to draw in all of the diagonals, but no matter where I draw a diagonal in this figure, it's always inside. Same thing over here. Connect any two corners that aren't next to each other, you'll end up with a line segment that's inside. Now, on these ones, if you pick the right corner, so those aren't next to each other because there's a corner in between right there, right? But if you connect these, then you end up with a diagonal that's outside. That's what makes it concave. Okay? All right. So let's talk about how to name polygons. The most common way to name a polygon is by the number of sides. So a triangle is a polygon with 3 sides. You've probably heard of a triangle. Okay. Sometimes for 4, people will say, oh, a square. Well, a square is a polygon with 4 sides. So is a rectangle. But wait a second. So is a parallelogram. So is a trapezoid. So is a rhombus. So those are all types of 4-sided polygons, but a quadrilateral is a name for any type of 4-sided polygon. So that covers all of the bases. Okay. All right. 5 sides would be a pentagon. So like the Pentagon building is a 5-sided polygon if you look at a bird's eye view of a Pentagon building. Hexagon is a 6-sided polygon. 7-sided is a heptagon Okay, sometimes some books use septagon, and that's actually also acceptable. You could also do that with an S. I'm just going to stick with heptagon because that's what our book uses. So, but I'd be all right with septagon. Okay. Then we've got an octagon, just like an octopus has 8 arms. An octagon. Oh, and I spelled that wrong. Should be an A there. Whoa! I switched the A and the O. There we go. That looks better. All right. So an octagon has 8 sides, just like an octopus has 8 arms. 9-sided polygon is called a nonagon. Decagon is 10. A decade has 10 years. A decagon has 10 sides. Okay, I'm skipping 11 for now, and I'll talk about that in a second. 12-sided figure is a dodecagon. Okay, and these are the ones that you really need to know. So what about 11? Well, we're just going to call that an 11gon. It has a name. I'm blanking out on what it is right now. But, you know, we could go on forever, and we don't want to spend all year memorizing the names of polygons. So anything that's not on this list, say we have a 47-sided polygon, we'll just call it a 47gon. Okay? Or we could have a 999gon or whatever, right? So these ones in the list are the very common ones, and the ones that you'll be expected to know. So you probably know a lot of them already. So the ones that I find that people don't know as well are these ones, but I don't know. So just need to spend a little time memorizing those, I guess, if you don't know them. Okay, let's move on. Let's get into we're going to get into perimeter and area. So we're going to start with some basics. Okay, a rectangle. I know you know what a rectangle is, but let's define it. It's a quadrilateral, has 4 sides. It is a quadrilateral that has 4 right angles. Okay, so does that mean that a square is a rectangle? A square actually is a rectangle. It's a special type of rectangle. Okay, it's a rectangle where all 4 sides are congruent. Okay. All right. So if I call this bottom side of this, let me separate this here, the base. So I'm going to use a lowercase b. Okay. And then I'll call this side the height. I'm just going to write an H and I'm going to write out the word height. Okay. Now the base could be on the side and the height could be on the bottom because I could do that, right? So base doesn't necessarily mean it's on the bottom. It's just the base and the height are going to be perpendicular to each other. All right. But another thing that's true about rectangles is that the opposite sides are congruent. So if this is H, this is H. If the bottom is B, the top is going to be B. Okay? Now the perimeter is the distance around the figure. So if you start at a corner and walk all the way around, it's the length that you've walked. So that means you will have walked B plus H plus B plus H. Okay? And if we simplify that, B plus B would be 2B, and H plus H is 2H. Now, do you really need to memorize this formula? I don't think so. Just remember it's the distance around the outside, so you just add up all of the sides for the perimeter. And that's going to be the same for any figure, okay? The area, you do definitely need to memorize this. You probably know it already. It's the base times the height, okay? All right, so let's try this out with a real live rectangle. So let's say I've got, actually let me put in some units here. I'll say that these are meters. Okay, let's find the perimeter. Well, hey, if this side's 2 meters, this side's 2 meters. If the bottom's 7 meters, the top is as well. So the perimeter, I can say that the perimeter is 2 plus 7 plus 2 plus 7. So 9 plus 9 would be 18. and then my units are meters. There's my perimeter, okay? Area, I'm just taking 7 times 2, base times height. So that's going to be 14. Okay, now for my units, still got meters, but area is always square units. Okay, in the perimeter, it's a linear distance. You could measure that with a ruler, but you can't measure area with a ruler. You're going in 2 dimensions, and that's why the units are always squared. Okay. All right, and now moving on to a triangle. So the reason I started with a rectangle is because, well, let me go back up to my picture here. If you cut a rectangle in half, like that, hey, you got 2 triangles. Okay, so if you know the area formula for a rectangle, you can just divide it in half to get the area formula for a triangle. Okay, so the area formula, you can write it like base times height divided by 2, or 1/2 base times height, whatever you prefer, it doesn't really matter. Dividing by 2 or multiplying by 1/2 will give you the same results. Okay, and let's say I'm using the bottom side of this as the base. Okay, the height it has to be perpendicular to the base, and it has to also connect to the opposite corner. So the height is going to be this distance. Okay. All right. So let me get that down. The base and height must be perpendicular. So they must be at a 90-degree angle. Okay, and the symbol for perpendicular is looks like that. So now upside down, uppercase T, like so. Okay. All right. So moving on to this next example, I'm going to put some numbers in here. Let's say that's 2, 3, 6, and 8. Okay, and the 8's supposed to go for that whole side there. Okay, so let's find the area here. So I'm going to use this formula right up here, but I have to pick what the base and the height are. So some people might use 3 and 6. And it might work if I knew I had a 90-degree angle in this corner, but I don't know if I do. Maybe it's 93 degrees. Maybe it's 100 degrees. I'm not sure. Maybe it is 90 degrees, but I don't know for sure. So I have to use the right angle that I have that I know is definite. Don't assume something's a right angle unless you're told that it is, okay? So that means I'm going to use this as my base and this as my height, okay? So I'm going to use the 8 and the 2. The 3 and the 6 are just distractions there. So my area, 1/2 base times height. Okay, and then 1/2 of 8 is 4. So I've got 8. All right, now this time I don't know if it's meters or inches or miles. So I still want to say units here though, because I want to show that those units are squared, even though I don't know what type of units they are. Okay. All right, and I'm not going to talk about triangle perimeter, but you just add up 8 plus 3 plus 6 there, right? Okay, so we still haven't done anything on a coordinate plane, so let's go ahead and do that. So one more problem. We're going to find the area and perimeter of a triangle on a coordinate plane. So hey, there's a coordinate plane, okay? So find the area and perimeter of triangle ABC, and we're going to round answers to the nearest tenth if necessary. Okay, so let's plot these points. 2, 2, 2 to the right, 2 up. Here's A. B is at 3, -1. And C is at -2, -1. Okay, and I'm going to draw in This is a triangle, so I'm just going to connect the dots. And I could use a ruler if I wanted to make this pretty, but I don't care right now. Just getting the basic triangle down. Okay, so finding the area and perimeter. So in this particular problem, I actually think the area is easier. I'm going to start with the area, okay? So usually if I have either a horizontal line or a vertical one, I'm going to use that to my advantage, okay? And I've got a horizontal line right here. The bottom of this triangle is horizontal, which makes it really easy to find the length of that line segment. Now I could use the distance formula, but if it's a horizontal line, I can also just count the spaces. So I'm thinking, okay, 1, 2, 3, 4, 5. Okay, so feel free to use the distance formula, but feel free to count as well if it's just a horizontal or vertical. Okay, so I know that's 5. Now when I'm looking for the perimeter, I'm not going to be able to count when I've got lines that are tilted like these two. I'm going to have to use the distance formula for those. But when I'm looking for the height, I know it's going to be perpendicular to the bottom of this. So I know it's going to be at a right angle going to the opposite corner, like that, okay? And at height, I can also count because it's a vertical line. So I'm just thinking 1, 2, 3. This is 3 units. And that means I can find the area already, okay? So my area, 1/2 base times height. Base is 5, height's 3. Okay, so I like to, here I'm going to multiply 5 times 3 first. So I'm taking half of 15. That's not going to come out even. It's going to be 7.5, right? You could write it as 15 halves if you wanted to, but I'm going to write it 7.5, okay? And I don't know the units here. This is my area. But I know they're square units, so I'm going to say 7.5 units squared. Okay, so halfway done. We get the area done, but we still need the perimeter. Okay, so I'm going to use this as part of my perimeter, but I still need the other two sides as well. Okay, so let's look at AC. So AC is this side here, right? AC. So I'm just writing that down so I remember what I'm working on. I'm going to find the distance between points A and C. Okay, so I'm going to use the distance formula here. So I'm just going to write down the formula so that I have it to plug into. Okay, so the square root, the squared difference of my x's plus the square difference of my y's. Okay, so all right, so I'm going to call this x sub 2 and this x sub 1. So I'm going to 2 minus negative 2 here. Okay, so I've got a double negative there. I've got to watch out for that. And then I've got 2 minus negative 1 for my y's. And I've got another double negative. Okay? And when you've got a double negative, that's the same as adding a positive. Okay? So this is going to be, so, you know, you can do this kind of thing if you like. Change that into a plus and change this into a plus as well. So that means I've got 4 squared and 3 squared. Okay, next I'd want to do the exponent on both of these. Make sure I'm not off screen there. So 16 plus 9. All right, and that's going to come out to the square root of 25. Remember to do the addition before you do the square root. So this isn't going to be the same. Some people might say, oh, 4 plus 3, because the square root of 16 is 4, square root of 9 is 3. That would put me at 7. But if you do the addition first, I get the square root of 25, and that's 5. Okay, so I'm going to put this into my picture so that I don't forget. So that was this side. Okay, and now I have 2 of the 3 sides down. I need 1 more, so I need to find. I'm going to use the distance formula on AB on the right side of this triangle. Okay, I'm going to use this formula. So x2, I'm going to do 3 minus 2 and square it. And then negative 1 minus 2 and square that. Okay, and again, you can go the opposite direction. You could have done 2 minus 3 and 2 minus -1, and you'll wind up with the same answer, actually. But you got to be consistent which way you're subtracting. So, got 1 squared, and this would be -3 squared. Okay, 1 squared is 1. 1 times 1 is 1. -3 times -3 is 9. Okay, now that's not a perfect square. So I'm going to put it into a calculator and round to the nearest 10th. So let's see, square root of 10 is going to come out to about 3.2. Some people look at this and say 3.1, but they didn't round that correctly, right? 3.16, that 6 pushes me closer to the 3.2 than I am to 3.1. So I'm going to round this to 3.2, 3.2, and yeah, use this squiggly equal sign to show that this is not exact, right? This is rounded, so that's important too. So putting this back in the picture, this side then is about 3.2. Okay, and now I can find the area by adding those, sorry, not the area, the perimeter by adding those three numbers together. So my perimeter is going to be about this. And I said about because the 3.2 is not exact, so that's going to give me about 13.2. Okay, and you can write out units if you want to, but you don't really have to for perimeter. If you knew it was meters or centimeters or whatever, you definitely want to put that in. But it is really important to have it for the area just to show that the units are squared. Okay, and that's the end of the section.